All right, good morning, guys. Sorry that the video did not load up properly, so I'm going to do this a different way today. Okay, so if you look at example number 1, we can just take the derivative, right, because dy dx just means derivative. So I would just say y prime equals, or dy dx, if we want to write dy dx, equals, and then we would get 4x plus 3, right? Okay, so that's pretty easy. The difference is, though, if you look at something like number 3, how are you going to get the y by itself to do what we just did here in number 1? Kind of hard, right? All right, so what we're going to do is we're going to take a different tactic, and this you've done before in pre-calc, and we're going to do something called implicit differentiation. So I'm going to look at this first term right here, and I see that I have product rule. So I'm going to group the 2 and the x as 1, and then I'm going to have that be multiplied by the y, okay? All right, so here we go, product rule. So I'm going to take the first times the derivative of the second. Now the derivative of y we know would be 1, but with implicit differentiation, anytime we take the derivative of a y, we're going to write dy dx. Now, that's the first times the derivative of the second. Now we're going to do plus the second, which would be y, times the derivative of the first. So the derivative of 2x is just 2. And with implicit differentiation, whenever I take the derivative of an x, I'm going to write dx dx. Okay, let's go to the next term, plus y squared. So that would be 2y, but it's a y that I just took the derivative of, so I write dy dx equals derivative of an x, which is 1, dx dx, plus y, which is 1, and then dy dx. Okay, now let me just show you a couple things. I'm never going to write it like this every single time, because I know really that dx over dx is really just a 1. So what's really inside this parentheses is just a 2. And look down here, when I took the derivative of this x, I got dx over dx, which is really, again, just a 1. So the shortcut for implicit differentiation is anytime you're taking the derivative of a y, you have to write dy dx. But if you're taking the derivative of an x, you really don't have to write dx dx. So you're not going to see me write it in the next question. Okay, but just, I wanted to put it there for right now. So let me just simplify this a little bit. So I have 2x dy dx plus 2y plus 2y dy dx equals dy dx. Oops, and I really should have a plus 1 in here, right? I'm going to stick it at the end, I'm sorry. So plus 1. All right, now the next thing that we're going to do is we're going to try to get all the dy dx terms to one side of the equal sign, and everything that doesn't contain a dy dx term is going to go on the other side. I tend to keep anything with the dy dx on the left-hand side. I don't know, it's just a thing. It doesn't matter, though. Okay. So that means I have to move this dy dx over, and that's going to become a negative, right? So minus dy dx. And then on the right side of the equal sign, well, I already have that 1, and I'm also going to move this 2y. Okay, so that's going to be minus 2y. All right, next step on the left-hand side, I'm going to factor out a dy dx, which is going to give me 2x plus 2y minus 1 equals 1 minus 2y. Okay, and last step, I'm going to divide out this 2x plus 2y minus 1, because what that's going to do is that's going to get that dy dx by itself, which is what we want, because that's what we're trying to find. So lastly, just to make it look a little pretty and clean, final answer is 1 minus 2y over 2x plus 2y minus 1. And there you go. All right, so I'm just going to do a couple more for you just to make sure that you got the hang of it. So I have 2x, but that's the derivative of an x, so I don't need to write dx, plus 2y, that's a derivative of a y, so I do need to write dy dx, equals. Then I've got product rule on the other side, so I'm going to take the first times the derivative of that y, which is dy dx, plus the second, which is the y, times the derivative of the first, which is just 6. I don't need to write dx. Okay. All right, so everything with a dy dx, I'm going to put on the left side of the equal sign. So I'm going to move over that 6x dy dx. And then everything that doesn't have a dy dx is going on the right-hand side. So just like that. Okay, next step, we're going to factor out the dy dx on the left-hand side. And lastly, we're going to divide out whatever is attached to that dy dx, because what that gives us is the value of dy dx. Okay, so just to make this look a little neat and pretty, we've got 6y minus 2x, and that's all over 2y minus 6x. Okay, no need to simplify. You can leave it exactly as is. All right, next one I'm going to show you is number 7. So that's 3x squared. We've got product rule. Be careful, you have a minus sign. So be very careful when I'm doing product rule. That is going to be my first term. Oops, I just went over the squared, but let me see if I can undo that. Yeah, I don't know if I'll be able to get it in there. There we go, that's a little bit better. Okay, so product rule. So we're going to take the first times the derivative of the second. Okay, plus the second, which is y, times the derivative of the first. Now the derivative of the first is negative 2x, not positive, negative 2x. Okay, plus, then I'm going to take the derivative of the 4y squared, which is 8y, but it's a y, so we write dy dx, equals, and the derivative of 6 is just 0. All right, so let's keep all of the stuff containing the dy dx. Let's keep that all on the left side. And everything that doesn't have a dy dx is going to the other side. Okay, then we're going to factor out that dy dx and get negative x squared plus 8y inside. And then the last thing we're going to do is get the dy dx by itself by dividing out what's attached to it. All right, so final answer, dy dx equals 2xy minus 3x squared, and that is all over negative x squared plus 8y. Okay, you may want to pause this video, but I did 9 and 11 for you, so I would probably suggest that you try them first and then check your answers with what I have here. Okay, skipping ahead to number 13, I did the implicit differentiation for you, so you can see what dy dx is right here. Okay, and if you need to pause the video to just check to make sure that you would get the same answer, go ahead and do it. Now, what they wanted was the equation of the tangent line. So y minus y1, actually, let me back up a second here. Okay, so yes, equation of a tangent line is y minus y1 equals m times x minus x1. Well, look, they gave you the x1 and the y1 already. All we need is the slope, and this is slope. But we can't put this in for our m. However, we do have an x and a y value. So what we do is, let me just show this to you in red so you can see it. When we want to evaluate the derivative, we can put this vertical line, that's like a little evaluation line, and then at the bottom you just write what points you're putting in there. So I'm putting in the point 1, comma 2. So everywhere I see an x, I'm going to plug in an x value of 1, and everywhere I see a y, I'm going to plug in a y value of 2. So here we go. So negative 1 minus 2 times 2 minus 2 times 1 all over 2 times 1 minus 2 times 2, and that's a minus sign. Okay, so in the top here, in the numerator, I get negative 7, and in the denominator, I get 2 minus 4, which is negative 2, right? So I know then that my slope, my dy dx, evaluated at that point, is going to be 7/2. All right, so then I just do y minus y1 equals the slope times x minus x1. And that's it. Okay, so your homework is to do pages 1 through 3, the even numbers. I will put, I'll scan the answers up onto Google Classroom. I'm probably not going to do that, though, until after class tomorrow, because I want to just make sure that everybody has a chance to work through them first.